So let's take a look at this question. So the question asks the position s in meters of an object moving along a horizontal line at time t in intervals 0 where t is greater than or equal to 0 but less than or equal to pi over 2 in seconds is given by the equation s of t equals 6 times sine of t plus 3 over 2 times t squared plus 8. What is the velocity of the object when its acceleration is 0? So obviously when you first look at this question, you feel a little bit daunted because you've never really heard of, physics. I don't, when you've only taken calculus and you haven't taken very advanced physics, you won't know, but this is pretty simple, and I'll break it down for you. So basically, the function in and of itself, or s of t, is essentially the equation for the position. This is something you need to know. And the derivative of that, um, let's see, of that function is essentially the velocity. So simple enough. And the next thing you need to know is that the second derivative of this function yields the acceleration. So using this, we can solve for this question. So first, we already started off with the position equation. So that's 6, but it's just 6 times sine of t plus 3 over 2 times t squared plus 8. So this is our equation. And basically, we're in the position phase right now, and we want to get to the velocity, but we also want to know the acceleration because it's asking for when the acceleration is 0. So let's do it. So obviously, in the derivative of this turns sine of t turns into cosine of t because the derivative of sine is cosine. So 6 times cosine t. And using the power rule, we'll take this down and we'll get 3t. And we subtract 1 from the power. And obviously all constants, the derivative of a constant is 0, so we'll just leave that blank. So now we have velocity. Now we also need to find acceleration because as I mentioned before, we want to find the velocity of the object when its acceleration is 0. So let's do that. I forgot it there. Or can also be indicated. Let me actually fix this for a second. This can also be indicated or is commonly indicated as S prime or S double prime. So if we do this, we see that the derivative of cosine is negative sine, so that's essentially negative 6 times sine of t, and we know that it'll be the coefficient of this, so it's essentially that. And basically, the problem wants us to know when is the velocity of the object when its acceleration is 0. So when the acceleration is 0, this must be equal to 0, meaning we just have to set this acceleration equation that we just got to 0. And we find that if we subtract by negative 3 on both sides, then we're left with negative 6 times sine of t equals negative 3, and then we divide by negative 6 on both sides, and we get sine of t equals 1/2. Now, what value of t will yield 1/2 for sine, so we just draw a quick unit circle and we find out that here this is √3/2, 1/2. This is √2/2, √2/2. This is obviously 1/2 √3/2. So we find that sine of t comes from pi/6. So we take this value we got from here and we essentially plug it into the velocity equation that we got here because it's asking for what is the velocity of the object when its acceleration is 0. We take that and we get 6 times cosine pi/6, which is cosine pi/6 is √3/2, so 6 times √3/2 plus 3 times pi/6, which is 3 pi/6. And if you multiply this, this becomes 6 times √3/2 plus, if you simplify this, this becomes 1 pi/2. So there you have it. Your final answer is this, which is equivalent to C, which is going to be your final answer. Thank you for watching, and if this you enjoyed or you felt helped by this video, don't hesitate to drop a like and subscribe, and I'll see you in the next video.